Hi, this is the group presentation for Group 5 in the class 262. This is a presentation that we came up for the Random Company LLC, the program that we've been working on. And we have Brian Flanders, Donald Nelson, Zane White, and Stephen Laney here for this presentation. And we're going to go ahead and start with Donald at this moment.
Thank you. All right, so we're going to start off first with our business problem. Random Company LLC, it develops software, and we need to share that software amongst developers. So in order for us to comply with Sarbanes-Oxley, we need to store all transmission and communications between our developers with source code and text. Random Company LLC must also keep this software on private servers stored on site. And all electronic communication and transmission must be transmitted via HTTPS secure communications. Now, the risk analysis for our proposed plans is the pros of transferring data over secure mediums so that no one can take the data during transit. And we also will have the history and log tracking of all work and communications. Those are all pros for this. However, some cons for this risk analysis is that the disaster recovery will be at risk due to information residing on site. We will not be using any cloud servers or anything of that sort. So if any natural disasters occur and our building collapses or we lose the servers, the server crashes, we have now lost all information. So that's a pretty negative con. And secondly, if we proceed with this project and it fails, we will be wasting quite a bit of money. So initially, the hardware costs, we're going to be needing to purchase a few servers, about $20,000, and some new computers for our developers, which comes out to about $40,000. We expect this development to take about 12 months with all 20 employees who make about $70,000 a year, which makes up $1.4 million. So our total cost for our project right now is $1,460,000 over the course of that year in order to develop this software. Now, the proposed project is that we're going to be building our server infrastructure on site, storing the database and the software code and transmission logs. We're going to be creating our custom application to support secure HTTPS transfer of the software between the employees. And we're going to be needing to log the code transmissions to our database to comply with Sarbanes-Oxley. This will also mean that we will need to purchase our certificate, our HTTPS certificate to support secure communications. That will be an additional cost, a yearly cost that we'll need to support. Now, our chosen software development lifecycle is that we'll be using the Agile method while incorporating daily scrums. Because this is an in-house developed software, we believe that that there will be many changes throughout the course of what we expect to build versus what we actually build. And that means that we will need to be fluid as we work through these requirements. The needed changes will be discussed in our daily Scrum meetings to make sure that it is complying with the requirements that we need to meet. Now, our desired team composition is we'll have a project manager in charge of it. We'll also need 3 team leads, a database lead, a back-end server lead, and the front-end client lead. And we're going to have the software engineers that are doing most of the coding for it. And towards the end, we'll be needing quality assurance analysts to test and retest the software to make sure that it works as expected.
Okay, so the quality assurance standard and measures that we're going to be putting into effect to make sure that we don't we have the least amount of data loss, that we're being as efficient as possible, and that we're maximizing the quality that we want out of this project. We're going to make sure that we're testing and that we process improvement throughout. We're going to be assessing the estimated possible risk and reporting throughout the development of the project as we go through to make sure that anything that needs to be caught, that we're catching those along the way. The project management plan that we decided to go with was, and we already discussed this a little bit before, but it's going to be the Scrum management methodology as we're incorporating the Scrum sprints. So we're going to use the Scrum sprints to handle the workload until the project is fixed and completed. And we're going to be focusing on the essentials for the project, making sure that 100% of the communication is stored and that all transmission is logged and secure. And to be able to have a separation of workload by breaking down the load into manageable tasks. For technical description of the technical problem that we had and that we're hoping to be able to solve with this program, in order to comply with the Sarbanes-Oxley Random Company LLC, we must store all transmission of code and communication on a private server. All communications and transmissions must be secured through HTTPS certificates. This software will monitor our compliance and will be developed in-house. So project management detail. So the duration of this project, throughout the duration of this project, we expect there to be 41,600 hours. And for the cost, the total cost of that, for the hardware to be 60,000, the annual salary of employees to be 1,400,000, and the SQL licenses that we're going to have to purchase are probably going to be around 4,000, bringing our total cost to 1,600,000 or 608,000.
This is the system use case diagram showing what systems look like and how they're functioning. As you see, the actor communicates with the J messaging frame, which has different parts like the text area panel and the J button panel that it pulls into it, and the actor accesses the J messaging frame and then sees those different parts that are being included. And then it communicates with the server where it stores the files and makes any necessary filter choices. This is the basic class diagram that shows how it communicates with the different classes. Pretty much the same as how the system use case looks. Then we have our sequence diagrams, which show specific communication with different parts of the messaging frame and different classes and how those open the files and close them within the system.
Okay, and this is Brian Flanders here. I'm going to go ahead and talk about our UML state diagram. So we had created this diagram here to talk about the different states that the software would be in and the different functions of those states. Fairly straightforward since we're just doing that program that'll pass the data back and forth in between, our own environment. So wasn't too complicated or needed a lot to go with it. So fairly straightforward and simple. I think that's it for the state diagram. On our next slide, we just list basically all the class files that we have and just have an index there for reference and for our developers. And fairly straightforward there. And as far as we did create user documentation since we have our working software product, and we'll be attaching that so that you guys can go through and actually compile and actually test the code that we've created for the program. And we created a technical support, or added it to our technical support document there, so you guys can have access to that. And with that said, these are all the, of course, references that we use in our presentation. Pretty straightforward there, but we want to thank you guys for considering this, and I think it'll be a super successful piece of software that we create and be able to add it into our collective, so to speak.